In the next video, we will discuss this famous fundamental theorem of calculus, but first I wanted to give a quick idea of how this problem of computing antiderivatives arises in applications. Now, sometimes it's pretty straightforward. You're just given the derivative of some function and you want to find what this function is. But in many applications, it's not going to be so straightforward. And often we do not know what the function is, and we also do not know what the derivative is. But given the information that we do have in this problem, we can often first compute this derivative, and then if you know how to compute antiderivatives, then you can figure out what your function is. So, for example, one application of this type will be to computing volumes. So, let's say we want to compute the volume of a glass. Now, in real life, you would probably just take a measuring cup, pour some water into this glass, and the measuring cup would tell you what the volume of the glass is. And surprisingly, in calculus, we are going to do something very, very similar. So, as we fill this glass with water, we can see that the volume that is filled by the water, it depends on this height of the water level. So we can think of the volume as a function of the height. And if we know the shape of the glass, so for example, if we know the diameter of the glass at any given height, then it's actually not that difficult to figure out the rate of change of the volume in terms of this height. Or in other words, the derivative of this volume with respect to height. Now, in this particular case, it will be pi r squared, where r is the radius, or half of the diameter. And once we have the derivative, if we know how to compute antiderivative, we can figure out this volume as a function of height. So actually, this will give us not just the volume of the entire glass, but it will also give us the volume of the glass up to any level. Now, of course, we will come back to this example later in calculus, but here I just wanted to give it as an illustration of how antiderivatives usually appear in applications, and so why it's so important to learn how to compute antiderivatives. And in the next video, we will take a look at another example of this so-called fundamental theorem of calculus, where we'll discuss the same idea that we saw here in more detail.